Hello students. In last lecture we have discussed how to fit the curves, straight line and parabola. In this lecture we are going to discuss about the fitting of the curve of the form y equals to a into x to the power b, that is third type. To fit such curves we are required to convert this in the form of a straight line in this form by taking log throughout. If we take log for this equation, we are getting log y equals to log a plus b log x. Then we write this log y as capital Y, log a as capital A, small letter b as capital B, log x as capital X. Then this is the equation of the straight line. We need to find capital A and capital B values. We know how to write the normal equations for a straight line, which is discussed in last class. So for this equation, normal equations are these two. Now solving these two normal equations, we are getting the values of capital A and B. But actually we want the values of small letter A and small letter B, and they will be got by these two relations. Small letter b is capital B and small letter a is e to the power a. So small letter a is e to the power a and small letter b is capital letter B. Substituting these values of small letters a and b in equation 1, we are getting the equation of best fit of equation 1 type. Students, now we'll discuss some problems on this as well as straight line and parabola. The pressure and volume of a gas are related by the equation P into V to the power gamma equals to K, where gamma and K are constants. Fit this equation to the following set of observations. So this is the given data. We are required to fit such type of equations. Let us call this equation as equation 1, P into V to the power gamma equals to K. Now, as explained earlier, let us take log for this to reduce this into a straight line. Log P equals to log K minus of gamma log phi. So this we have to rewrite as P equals to K into phi to the power gamma, then take log, we are getting this. Now this is log P capital Y, log K is capital A, minus gamma is plus B and log phi is capital X. Now this equation 2 is a straight line. We need to find the values of A and B, and the normal equation of such straight lines are of this type: two equations, two constants and two equations. To find the values of A and B, we need to construct the table. We know how to construct the table. First two columns are for the given data. Next, here in normal equations, summations are for capital letters, and how to find these capital letters we know here by the substitution. Capital X is log V, capital Y is log P, and x squared, capital X squared and capital X into Y. By using these values, find capital X as log phi, capital Y is log P, then x squared means x squared, x into Y means x into Y, corresponding values. Complete this table. Find the column sums for only those columns which are summations here in normal equations. So capital X is required, its sum, capital Y is required, its sum, capital X squared is required, its sum, and capital XY is required, its sum. So summation of X is minus 1.7138, summation Y is 2.4204, summation X squared is 1.5746, and summation of XY is minus of 2.2347. Substituting these summation values in the normal equations, we are getting these 2.4204 equals to 6a, where n equals to 6 here, number of observations, plus of minus 1.7138b. Second normal equation, minus 2.2347 equals to minus of 1.7138a plus 1.5746b. Solving these two equations, we are getting capital A and capital B values. Capital A is minus of 0.003, capital B is minus of 1.422. But actually we are in a need of small letters k and gamma. So here we have taken log k as capital A and minus gamma as B. So k equals to e to the power a, capital A is this, so e to the power capital A, this value gives k as 1.039, minus gamma is B, so gamma is minus B, so it is 1.422. So k equals to this, gamma is this. Substituting these k and gamma values in equation 1, we get the required equation of best fit as p into v to the power 1.422 equals to 1.039. This completes the solution for this problem. Now let us see next problem for parabola. Fit a parabola of second degree y equals to a plus bx plus cx squared for this data. So we are required to fit this parabola. In parabola a, b, c, three constants are there. So there exists three normal equations. For writing these normal equations we have seen in last lecture. Now construct the table. How to construct table, that also we have discussed in last lecture. First two columns for given data, then subsequent columns for each summation present in the normal equations. Complete this data, this table. Find the column summations. So summation of x we are getting as 10, summation of y we are getting as 8.9, summation of xy we are getting 21.1, summation of x square we are getting 30, summation x squared into y we are getting 66.3, x squared y 66.3, x cube is 100 and summation of x4 is 354. Substituting these summation values in the normal equations, we are getting these three equations correspond to each of these normal equations. Solving these three equations, we are getting small letter a as 1.078, small b as 0.414, small letter c as minus 0.021. Substituting these three values in equation 1, we get the required equation of the parabola as y equals to 1.078 plus 0.414x minus of 0.021 x squared. This completes the solution for this problem. Now let us see last one more problem on straight line. Following table gives the production, it is in terms of 1000 units of a certain commodity in different years. For year wise here, production is given. These are in terms of thousands. This is 8,000 like that. We need to fit a straight line to this given data. Also, we are asked to estimate the production in 2020, in the year 2020. Solution. As straight line is asked, we know that equation of the straight line is of this type, y equals to a plus bx. And for normal equations for the straight line are summation of y equals to na plus b summation x, summation of xy equals to a summation x plus b summation x square. We know this. Now, if the values of the independent variable like this year bigger or larger, they can be reduced. They can be reduced by some modification. We'll modify these values. I'll take this as x equals to year, whatever this year, minus 1977. This 1977 can be any figure here. Better if you take here, even we can take mean of all these values. I have taken here 1977. So my intention is to reduce first value as 1. As here the difference is 10, constant difference 10. So we'll get here, if we get this as 1, then this will be 10, 21, 31, 41. This is actually 2018, 0 is missing there. Please take it as, consider it as 2018. Now small x is modified with this formula. X is this year minus 1977. So year 1978 minus 1977 is 1. 1988 minus 1977 is 11. 1998 minus 1977 is this. Similarly, for these two, we are getting 31 and 41. And y is kept as it is. Then subsequent next columns are corresponding to the summation in the normal equations. Xy and x square are required as in earlier case discussed. Now find the column sums. These are the column sums. So here we have written capital summation of x is 105, summation of y is 50, summation xy is 1336, summation x squared is 3178. Substitute these summation values in normal equations with the n equals to 5, n is number of observations here. We get these two equations. Solving these two equations, we are getting the value of a and b as a is 0.1644 and b is 7.7467. Substituting these values in equation 1, we are getting the required equation of the straight line of best fit as y equals to 0.1644x plus 7.7467. So this completes the first part of the solution. Fitting a straight line is completed up to this. Further, we are expected to estimate the production in the year 2020. But our equation is in terms of small letter x. So we have to convert that year in terms of x. So x is year minus 1977. Year is 2020 here. So x equals to 2020 minus 1977. X is 2020 minus 1977, which is 43. So substituting this value x as 43 in this equation, we are getting y as 14.8159. So this is the production in the year 2020. So this completes the solution for this equation. So dear students, with this I am closing this topic, curve fitting. For more number of problems, you can consult the textbook mentioned in the syllabus. Thank you.